Hello there, and welcome to another Pars for Physics A-Level tutorial. Today's lesson is static tension. The question: a mass of 28 kilograms is hanging from two ropes. What is the tensions in each of the ropes? Okay, the first thing we do is a free body diagram. So here's the mass, and here's the force down, mg. Here's our two ropes, T1, T2, and here's our components, and here's our angles, 50 and 60 degrees. Let's just give our components names: x1, y1, fx2, and fy2. Let's just drawing the tensions. You always pull on a rope, you never push, just to help you remember. So the tension is always away from the mass. Okay, the next thing we do is find some equations to help us. Now, fx1 equals fx2. This makes sense as it's a static force, it's no movement, so x1 must equal x2. The next equation, fy1 plus fy2 equals mg. Again, if you look at these two forces, they must equal mg. Okay, there's many ways of solving this mathematically, but I'm going to use the trigonometric relationship that sine over cosine is equal to tangent. And obviously tangent is equal to opposite over adjacent. So let's do the first. So the tangent of theta, 50, equals 1.19, and that is equal to fy sub 1 divided by fx sub 1. So we'll just quickly do that for the other one. So the tangent of 60 is equal to 1.73, which is equal to fy2 divided by fx2. So this one here, if we rearrange that, we will have 1.19 times fx1 is equal to fy1, and by rearranging this one, we will have 1.73 times fx2 equals fy2. So let's just put those together, and here's the equation. So as you can see, by solving for fx1, you could solve for fx2, it doesn't matter, they're equal to each other. But I'm going to solve for fx1, and then substituting it, we have this equation here. So what I'm going to do now, as I said before, fx1 is equal to fx2, so all I've done here is just replaced this with fx1 as they are equal to each other. So now all we have to do is a little bit of algebra. We'll just collect like terms, and we end up with 2.92 times fx1 equals 274. Again, if we solve for fx1, that is just simply 274 divided by the 2.92. That then gives us an fx1 of 94 newtons. Okay, so now we have our horizontal component. we can start solving for the tensions. So the cosine is equal to fx1 divided by t1. So rearranging that, you end up with 94 divided by 0.643, which gives us our tension 1, which is 146 newtons. So in tension 1 here, pulling this way, we have 146 newtons. And now just for T2 is the cosine of theta, which is 60 divided by fx sub 2 divided by T2, obviously the hypotenuse in the trigonomic function, gives us 0.500 equals 94 divided by T2. Rearranging to solve for T2 gives us a T2 of 188. So there we have it. We have 188 newtons in T2 and 146 newtons of force in T1. Well, I hope that was of some help. I look forward to doing more videos. I'll be doing some videos in all the A-level physics. This one's basically on forces, static forces. I will be doing some more. If there's any requests or anything you would like to see, please comment and I'll see what I can do. Apart from that, I hope you enjoyed that and I'll see you soon.